So 12.2, it says, how would the outcomes of the following scenarios be different? All students at PNHS are surveyed. They are asked if they drive to school. All seniors at PNHS are surveyed. They are asked if they drive to school. So in this case, if we look, there is a difference between these two. If you just ask the seniors, it's a much smaller sample, and therefore would have a higher probability since they're all over 16. It's actually pretty important. I had to write that down. So there's a condition here. It's not just the fact that you're a PNHS student, it's also if you're a senior. That narrows things down a bit, okay? So conditional probability, the probability an event will occur given another event has occurred. So in this case, the event that already occurred is the fact that there are PNHS students surveyed. The secondary event is that they were seniors. So it'd be, the notation would be the probability of A given B. This slash means the word given. Okay, and then just to recap, remember this meant the word or, which is called a union. This was the word and, which was called an intersection. And remember, we also had that little C, which was the complement. Oh, oops, sorry, the word not, which is the complement. Okay, so we're dealing with now what is given, all right? This given that. All right, anybody still writing this down? Okay. All right, so let's talk about this first example. It says, understand conditional probability. A student committee is being formed to decide how after-school activities will be funded. The committee members are selected at random from the current club members. The frequency table shows the current club members' data. What is the probability that a member of the club selected at random is a junior? Okay, so what's happening here is the entire junior class, okay? And what they're actually being used in, or what they're actually involved in. All right, so one method is to use frequency table to find the probability that the student chosen is a junior and that the student is a member of the art club. Now, if we take a look at this, here's our junior. Oh, come on now. And here's our art club. Let me get yellow a little better. Okay. So we're trying to find the probability given a junior an art club. And a couple other things you should be aware of is probability that they are a member of the art club. We have a total of 58 in that group. So you can only choose from the group of 58. So we're not dealing with totals, okay? Now, if we're looking at this first method, it says use the frequency table to find the probability that the student chosen is a junior given that. Those are key words there, okay? And it's used to indicate a conditional probability. So if we were going to calculate this out, again, I'm going to have the juniors, okay, over the art club. So this is going to be 16 over 58. So 16 total juniors over the total in the art club equals, if we reduce this, it'll be 8 over 29. Okay? Or 27.6%. Okay? Of art club members are juniors. Now, I know this was a lot of writing, but I really hope you guys are writing this down because it is really good notes in order to kind of keep the idea of what's conditional, what's independent, things like that. Okay, it's all about language here. All right, questions on this? Anybody still writing? All right. All right, what is the probability that a student is taking robotics given that the student is a sophomore? All right, so if we take a look at that, we are trying to find the probability of robotics given sophomore. Now we're missing some information here. We see definitely that we have 16 sophomores in robotics, but we don't have the totals. So we're going to write those totals down. So anytime you see a chart like this and the totals are missing, you're going to have to add it in. So if I do 16 plus 18, that leaves me with a total of 34 sophomores. Now sometimes we might need the ones over here. If I want to see how many total are in the robotics club, I would add 16 plus 24, giving me a total of 40 that are in the robotics club, and so on, okay? But you only need to worry about what you need. So in this case, I am going to find the amount of the robotics over the total number of sophomores. All right, so this is going to be, there's a total of 16 sophomores in robotics, and there's a total of 34 sophomores. Now 6 over 34 reduces to 8 over 17, or about 47%. Are there any questions on these two? All right, I want you guys to do the U-try-its on your own. They're on the back. There's 2 of them total, okay? Read through these, check them out. We'll go over the answers in just a few minutes. Show of hands, who's still working on these 2? If you are, just raise your hand. That's all I need. Everyone's got it? Okay. Okay, let's just check out the answer, and please tell me whatever questions you have. So here's the first one. 12 contestants are selected to compete in a game show. Suppose a contestant is selected at random. What is the probability the contestant is under 20 given the contestant is female? So there are 2 under 20 females, but in total, the amount of females was 6. So this is the probability of under 20 given female. So it's 2 over 6, which leaves us with 1/3 or 33%. Any questions on that one? Okay, next one. A group of people have volunteered in a research trial. Some will take the new medication and some will not, which is known as the placebo. What's the probability that a patient taking the medication showed improvement in health? So probability of health improved given they were taking the actual medication. So if you take a look at this chart, we have the health improved with the medication. Health did not improve with the medication. So there's a total of 118 people that are taking the medication. So if we take a look at this, we're going to take 53 over 118, which gives us about a 45% chance that if they took the medication, their symptoms improved. Questions on this? Okay, I do want us to kind of copy this down real quick. We'll go through everything, but this one says, for example, 3. In a survey of 50 male and 50 female high school students, 60 students said they exercised daily. Of those students, 32 were female. So here we have males and females, the ones that exercise daily and do not exercise daily. So that's how we kind of broke that up. And here's the chart we need to create. So you're going to want to write this chart down. It's going to make your life a lot easier if you do. All right, show of hands who's still writing this down. Anybody? Okay. Okay, so again, filling this in. So here I have just 28. Here I have 32. Here I have 22. And here I have 18. Now, if I wanted to find the totals, that's like almost adding on another column. So this would be 50. This would be 50. This would be 60. And this would be 40. So this is actually part A. This is what is known as a two-way frequency table. And it's often used in conditional probability that we've already been using. We just didn't give it a name. Okay. So part B, what is the probability that that a surveyed student who exercises daily is female? What's the probability that a surveyed student who exercises regularly is male? So the first thing we're going to do is we're going to find the probability that we have female given exercise daily. So this is going to be 32 over 60, which gives us a total, if we reduce that, 8 over 15, which is about 53%. Now we also need the probability that we have a male, given that they exercise daily. Now, if I look here, the amount of males that exercise daily is 28. And we have a total of 60 people that exercise daily. So this reduces to 7 over 15, which is about 47%. So what they're saying here is that probably females work out or exercise daily more than males do. Questions on this or anything that so far? All right, what is okay, so C, based on the survey, what can you conclude about the relationship between the exercise and gender? In this case, females tend to exercise daily more than males. Questions on that? And that's all based off the percentages that we have above. Okay? Questions, comments, concerns, anything that I can address? All right, you guys actually have a good chunk of time. I want the homework before the end of the period. Okay? Those of you watching home, have a great day.